Molecular formula. So an empirical formula represents the simplest or lowest whole number ratio of atoms in a compound. A molecular formula is the actual numbers of atoms in that compound. So let's say we had a molecule, say C2H4. So that could be the actual formula for that molecule. 2 carbons, 4 hydrogens. That would be a molecular formula. It would not be an empirical formula because the lowest whole number ratio would be to have 1 carbon and 2 hydrogens. That would be the empirical formula for this molecule. C2H4 would be the molecular formula. CH2 would be the empirical formula. However, some molecules, like let's say methane, has 1 carbon and 4 hydrogens. So its molecular formula, that is the actual formula for methane, and methane's empirical formula would be the same thing, because obviously one is the lowest whole number ratio. So molecules might have the same molecular formula as their empirical formula, or they may have a molecular formula that is some multiple of their empirical formula. So if you know what their empirical formula is, and you know what the multiple is, you can get their molecular formula. The multiple might just be a multiple of 1 to go from the empirical formula to the molecular formula, or maybe some other larger multiple of that. We can figure out what the multiple is because that multiple will apply to the mass of 1 mole of these things. So if you found the molar mass of 1 carbon and 2 hydrogens, and you found the molar mass of 2 carbons and 4 hydrogens, so the difference in mass between the empirical and the molecular formula, you knew what that multiple was, which would be 2, you know that to get to the molecular formula, you must have to multiply the empirical formula by 2, because the mass has been multiplied by 2. If it is the same molecular formula as the empirical formula, then the difference in mass between the two formulas, or molar mass between the two formulas, would just be 1. So once we know what that multiple is, we can figure out what the molecular formula is from the empirical formula. We'll work through 2 examples. So first one, given that we have a molar mass of the actual molecule. So the molecular formula of this particular molecule, we don't know what it is yet, but we do know that the actual molecule weighs 252 grams per mole. And if the empirical formula is given to us, the lowest whole number ratio is 5 carbons to 3 hydrogens, what we can do is we can find out, okay, well, what multiple would we have to get from the empirical formula up to the molecular formula. If we're given the empirical formula, this is a pretty easy calculation to do. Find the molar mass of the compound and divide by the molar mass of the empirical formula. So essentially, how much does 5 carbons and 3 hydrogens weigh in molar mass units, grams per mole, and what is the factor that it would take to get to the actual weight of the actual molecule? If 5 carbons and 3 hydrogens weighed 252, then we know that must be the actual formula for the molecule. We can quickly calculate out what 5 carbons and 3 hydrogens weigh. So we see that the actual molecules weigh 252. If you do the molar mass of carbon, 12.01 times 5 plus 3 times 1.01, the molar mass of the empirical formula works out to be about 63.07. So the empirical weighs 63, the actual molecule weighs 252, the multiple between that is 4. So to get to the actual formula, you must have to take the empirical formula, and the actual formula is 4 times as massive. We compare the molar mass of the empirical formula to the molar mass of the molecular formula and found the molecular formula is 4 times heavier. So we just apply that factor of 4 to the empirical formula, and we get the actual molecular formula of the compound. Given the empirical formula, we can find the molecular formula. However, if you don't have the empirical formula, you just have a little bit more work to do. 2 ways you could do this. You could find the empirical formula from the percentages. So let's say we're given the percent composition of a compound, and we want to know what the molecular formula is. You can take your percent composition, you could convert it to mass and go to moles and then find the lowest whole number ratio and get your empirical formula and then do the same thing we just did for this example here. Or you could do it in one step a little bit quicker. So let's say we had, so example number 2, we have 95.21% of a compound being carbon and the rest being hydrogen. We want to know what the molecular formula is from this data. We are also given that, same question as before, given that the molar mass of the actual molecule is 252 grams per mole. We have the percent composition. We want to know what the molecular formula is. So what we can do to try to get it done a little bit quicker is we can assume we have 1 mole of the sample. Now, if we have 1 mole of the sample and we know its molar mass, we know how much that sample would weigh. The molar mass of the sample is 252 grams per mole, so if we had 1 mole, we would have 252. If we apply the percentages to that mass, so we know that the percent carbon is 95.25%, this is that written as a decimal, and anytime we're calculating with percentages, you'd want to express it as a decimal value. So if we found out what 95.21% of 252 is, we would know the mass of carbon. We can take the percent of hydrogen written as a decimal and multiply it by the mass of the entire molecule, or the mole worth of substance that we have, and we would then have the mass of hydrogen and the mass of carbon. Taking the whole mass of the mole, applying the percentage to it, would give us the mass of carbon and the mass of hydrogen. Again, write the unit and label it so you don't confuse them. So now we have the masses of these two things, and we can take those masses and convert them to moles. So take the mass of carbon, use your conversion factor, cross off the mass. We are now dealing with moles of carbon. Do the same for the hydrogen, and we now have moles of hydrogen. Now, we're not trying to find the empirical formula, so we're not going to find the lowest whole number ratio between these two things. We want to know the actual molar ratio between, look at that, carbon, hydrogen, between the carbon and the hydrogen. So that is it. That is the molecular formula. That is the actual molar ratio between those two, because those are the actual masses of those two in the substance. And obviously we don't want to write it as a close to a whole number, being as this is a molecular formula. We want it to be an actual rounded whole number. This is a very small amount of rounding we're doing as a percentage, and so saying that there's 20 carbons to 12 hydrogens, that would be the molecular formula. The alternative way would be to go back to your percentages, find the empirical formula, and then find the multiple that it takes to get to the molecular formula. You would end up with the exact same answer, C20H.